Hi guys, and welcome to our next video. This video is theoretical and it's going to be all about explaining the session hijacking attack. What's a session hijacking, what does it mean, what's in its core, and actually how to prevent it, how to protect from it, and therefore how can you implement such an attack. So actually before we actually do that kind of attack, we need to know for sure how it works, what is it actually, and to actually define some of core principles for this attack, for example, man in the middle. So this is going to be a theoretical lecture. I hope you enjoy, and let's begin. So what is a session? We need to actually explain that before we actually go for the session hijacking, because in order to hijack a session, we must know what's a session before that. So in the networking video, I've explained what's a session, but here I'm going to do it again because I need to be sure you know what's a session. So the session is basically a communication between two hosts, and the host, we say that it's a device connected to the network. So that's all it is. Session is just a connection. A session can be like multiple types. It can be, for example, bind shell, it can be reverse shell, it can be actually secure shell, it can be remote desktop, it can be visiting a website, it can be going and accessing some FTP servers, it can be anything. Just the connection between two hosts is called session. For example, when you go and connect to your FTP server from a client side, you connect to that server, and therefore while actually interacting with files, you are creating a session, so you're able to interact with that file. So download, upload, and like all the functionality FTP has. So this is just a session, a communication between two devices, two hosts, and one should be acting as a client and the other should be acting as a server. So in order to become a session. So as I said, for example, with the FTP one, the FTP server is standing there, you're accessing the FTP server. After you actually passes the authentication level, you are in the FTP server, and therefore you are accessing files, uploading and downloading files, and reading files actually. So you are in a session with that FTP server. So another example of session is that the reverse shell explained here. And as you see, the normal shell, the client type commands on the server, but in the reverse shell, the server actually types back and connects to the client. So this is the reverse shell, we've explained that too, but this is another example of session as well. So as you can see, there are both two examples of session. The normal shell is session, of course, but you are connecting to a server, and the reverse shell is again session, but the server is forced to connect to you. But there's a connection again, there's a session, so this is what the actual session means, the connection between two hosts. So the next thing I want to mention and actually explain, because we did not cover that before, is the actual cookie. So what's a cookie? Well, the cookie is basically a tool for authentication in web servers. So that's all it is. So for example, a cookie is just some variable, some information that is stored to your session ID, and therefore the server means that you are here and you are in that session ID. So for example, you can see in the graph below, there is a client and there is a server. So when you, for example, get some page, for example, getgoogle.com, you access that in the URL of your web browser, and this forces your machine to act and actually request a get method from that server. And when you successfully connect that server, the server brings you that page you wanted, that you requested, and therefore it brings a cookie with that page, so you now authenticated the session with that server. You not only have the session, you have authenticated session. So when the server sees that cookie, it's knowing that it's you. So the cookie can be used for many functionality, but the main one is for authentication in web servers. So as you can see, we have the server responding us with the get message, with the successful 200 message, okay, and therefore it's setting us an ID for a session using a cookie. And so therefore in the next get method, we have specified our get method, and it's done automatically, of course. You're specifying the get method, and therefore you're specifying the cookie as well. So now the server knows it's the same session, it's the same machine, the same host connecting to that server again, and therefore he knows that it is you. So this is just the cookie, is just a tool for web applications, for authentication in web applications. So that's all the cookie is. And there are multiple types of cookie, multiple variables of cookie, and therefore there are multiple instances of that cookie. So one can be used, for example, for authentication. The other can be used for the different session ID. Or for example, you can have a cookie. You can have a cookie for PHP session ID, which is again for authentication. But yeah, just this is the core principle of cookies, so that the server knows it's you. So therefore, we need to explain what's a hijacking. So now we know what's a session, now we know what's a cookie, and the session cookie hijacking, actually, because hijacking is, the session hijacking is actually a hijacking of cookies. The session hijacking is basically when someone is able to read your cookie, your session, and therefore he requests something from the server with that exact session, so that the server thinks that he is actually you, and therefore he give him access, he give him permissions, files, and many more stuff. Everything that you are about to do can the attacker can do as well with your session ID. So he's basically browsing the web server with your session ID, with your accounts, with your money, with your profile pictures, with your messages, and everything yours is actually his now. For example, when you make a change and actually modify some variables, modify something in your profile, the session cookie is the same until it expires, and it has expired time. The session cookie is the same, so when we request that again, he's gonna get the updated resources. So he basically is your machine. So the session hijacking is dangerous attack. As you can see, we have a victim. The victim is connecting with some session ID with the web server, and therefore an attacker is actually becoming man in the middle here, capturing your cookie, and therefore he's requesting something from the web server with the exact same session ID. So this is what the session hijacking is, like getting your cookies and therefore requesting something from the web server with your session ID, so pretending that he is actually you. So now I here mentioned what's man in the middle, and now we need to actually explain that. So what's man in the middle? Man in the middle is basically one of the most dangerous and hard to stop attack, because it's really hard to actually understand what's happening and trace back what's happening. The man in the middle is just a one person who is staying between you and your gateway, and he's like lying, he's tricking that he's the gateway for the client, and he's tricking the gateway that he is the client. So all the traffic is passing through him, so he can actually modify that traffic, redirect that traffic, play around with that traffic, and actually steal and see what's inside that traffic. So this is why it's so dangerous, because it's actually hard to understand. You connect to web server, you get the requested page, everything seems okay, the router sees packets, he redirects that packets, brings that back that packets, but everything sees okay on its side too. But the bad thing here is that someone actually accessed and saw what you saw, get the exact same packet as you get. So that's why it's the very, very dangerous attack. But the disadvantage of that attack is that man in the middle can be applied only if the attacker is in the same network as you. He cannot do man in the middle, he cannot sniff. Sniff means actually listen. He cannot sniff if he is not on the same network, because the traffic is actually flowing through, and he cannot capture anything. He must be in the same network as the victim. And of course, man in the middle can cause a lot of damage. The attack is mainly focused on actually stealing information, gathering information. It's not focused on about crashing something, but it can be done as well. For example, it can edit the DNS records, and when you, for example, access Google, you actually access a copy of Google, which is malicious with some hooks in it, as you, for example, mentioned in B framework. So when you actually set up a beef hook on your fake page, for example, fake article, and you force somehow the DNS to redirect everyone in that article, you're gonna hook a lot of browsers, and therefore you can use social engineering attacks, you can use paywalls there to deliver some paywalls and gain access, and this is the really, really dangerous attack. There's a graph for you here, and as you can see, we have a user, we have original connection, And that's how like it's working. The user is just connecting to a router and going to a web page. So let's say that here is the router. Now when the man in the middle comes, he spoofs that he is the router, and he spoofs that actually he is the client. So basically all the traffic, as you can see, is passing through it. You request that application, the man in the middle knows what you're requesting, he requests the exact same thing, he gets that response and brings it back to you. And as you can see, nothing unusual happens. You've entered google.com and you request and you received google.com, but the thing is that it can be a little delayed, but that's not going to cause any suspicious thinking. So nothing wrong here, nothing bad happening. But on the other side, the man in the middle knows what you requested, knows what you want, and knows what you received. So this is a really dangerous attack, and this is how they actually steal cookies and modify that cookies. So actually, how does that attack is working? The first thing is actually the attacker to be in the same network. Therefore, he needs to actually become man in the middle, so he has to lie and sniff the traffic, and actually why that he's the router and he's the client from the router side. And therefore he's gonna start to sniff all the packets, and when, for example, access some web page, he's actually going to sniff and see your session ID, your cookies. And therefore the next thing the attacker has to do is to actually use tools like burp or actually manually injecting cookies to actually browse the exact same web server, the exact same web page with your cookie. And this is how the attack is working. He needs to be in the network, he needs to sniff, therefore he gets your cookie, and therefore he actually accesses that web server using that special cookie. So when the attacker has the cookies, he just needs to inject it and therefore request that page with that cookie. So now let's talk about how dangerous that attack is. So for example, when you hijack a session, when you go and pretend you're someone else in the web, so the server authenticates you as someone else, you can get access to all of his resources. So let's say this is a bank account, let's say this is like another account, this is like something dangerous, something important and sensitive that you want no one else to see it. It can be like private messages, private savings, and just many more stuff, everything you can think of. And so you don't want anyone to get access to your private and sensitive information, right? So session hijacking can cause a lot of damage to a person. It's focused on users. The attack vectors are towards the users and not towards the machines and the servers. You are not getting a reverse shell with the cookies. You are not entering a machine with the cookies. You are not actually attacking the server and dosing the server with cookies. No. You are focused on users, your attack vector is toward the users, and you want to steal information, steal money, steal messages, steal photos from that user, steal something that he is hiding. So for example, it can be bank account, it can be like some message platform, it can be just anything. So it can extract, actually the point of session hijacking is to extract sensitive information. And therefore it can cause high financial losses, high sensitive information disclosure, and just this attack is really, really dangerous. You don't want to get actually aimed by that attack. So now we get to the point of prevention of the attack. So what can you do about preventing that attack? So the first thing is to actually don't let anyone become man in the middle, and this is done by tools or by firewall, which is actually watching over your ARP requests. The ARP is that request, that packets which authenticate on what MAC address, what IP stands there. And when someone becomes man in the middle, he's actually lying and editing that ARP request. And the bad thing about ARP is that they have no actually secure mechanism, and they trust every packet, they count every packet as trusted. So when, for example, someone say, hey, I'm the router to some clients, he sent in an ARP request and the clients say, yeah, sure, you are the router. They are not checking anything, they are not actually asking anything, they have no security mechanism at all. So every ARP packet is counted as trusted. And when someone actually changes that ARP packets, everyone says just okay, and starts actually sending packets to that specified IP address. So the error packet is just when on which MAC address stands what IP, and therefore there are tools that actually scans your network from time to time and just sees and comparing all the ARP requests and all the ARP packets. And if they find something unusual or some changes that they are not meant to be, they just warn and actually warn the system administrator or directly take some actions in order to disable that, in order to prevent some kind of man-in-the-middle attack. And also there can be like internal firewalls, internal IPS or IDS, which can do the same based on rules. They're gonna track the ARP packets, and if they see some suspicious changing and suspicious activity, they immediately can warn or even prevent such actions, for example, blocking that IP which changed and actually blocking on some port and just denying the access of that IP. So I think is just the first step of actually protecting from that attack, just to actually store some protection for man in the middle. And for example, the IDS IPS is a really good option to go. They just scan their packets and they take action or warn if something happens. The next thing you have to do is by the developer side, they have to use like secured cookie flags. They do not have to use like blank cookies, like non-secured ones. They have to be prepared and use cookies for algorithms for encryption and security. And therefore, the third and the best actually option of protecting from that attack is to actually, from the web application or any application there is, to use asymmetric encryption. So what does the asymmetric encryption means? Basically, every machine has two keys inside. One is public and one is private. And the private key is stored in the machine and no one else sees it. And the public key is stored everywhere in space and everyone can grab it. So every machine has two pairs, one private which no one sees and the machine shows that to no one. And therefore the public key which actually is spread to everyone and everyone can see it. So for example, when you access a page, that packet you actually send and receive, you get, for example, the public key from the server, you encrypt that public key, and only the server with its private key can decrypt it. Because if someone is in the middle and it captures the server's public key, he's not getting the server's private key, so he cannot decrypt that information. And this is like one of the biggest stops for such kind of attacks, because they cannot get the exact same private key, but only the private key of the server can encrypt its public key encrypted information. This is a really cool trick, this is a really cool way of actually doing such attacks, preventing such attacks. And nowadays most of the web apps, for example Google, Facebook, are using that. This is like how HTTPS works, how the security, what the security stands for. It's just encrypting the information, encrypting the packets, and it's like creating a session with different encryptions. For example, when you connect that page, the packets you send are encrypted with your with the server's public key, and when they receive to a server, they are decrypted with server's private key, and the opposite. When the server sends you a packet, it gets your public key, encrypts the packet with your public key, and only with your private key you can decrypt that packet and see what information are inside. So for example, when someone is in the middle and gets that packet, he won't be able to decrypt that, so he gets a bunch of numbers and letters. So this is how you can protect from such an attack. This is how you can actually implement and do such an attack. And now in the future videos, you're gonna see all that in action. You're gonna see how the security works, how can we intercept and actually see not secured packet, and what happens when we actually try to do capture a secured one. We're gonna see how to become man in the middle. We're gonna see actually the ARP request, the ARP packets, and we're gonna see all that in future in action. So I hope this lecture was interesting for you. I really hope you enjoyed, and really appreciate for watching, guys. So stay tuned and see you in the next practical videos.